All right, well, let's look at the next law, and that law is almost identical. It just says if the bases are the same, so they're both a in this case, if ever we're dividing, we get to just take the exponents and subtract them. So before, if we were multiplying, it was this times this. If we're multiplying, we would get to add the exponents. Here we're dividing, so we can subtract them. It's very straightforward. Again, it's only true if we can divide. So we can go, we are dividing here, so we can go 7 minus 2 is 5. Here we have the base. The bases are negative 4. 13 minus 5 is 8. And that's all there is to it. Only if the bases are the same. 10 is the base. 55 minus 22 is 33. Here we have 7. Now, I did mention this before. Anytime there is no exponent, that means it has an exponent of 1. So 7, and then 100 minus 1 is 99. Continuing on here. 8. So we have 7 minus negative 2. What? 7 minus... Let's maybe write this one up. So we are dividing, so we're going to go 7 minus, and the number is negative 2. So 7 minus negative 2. Whenever you're minusing a negative, you're actually adding. So this is not 7 minus negative 2. It's also thought of as 7 plus 2. 7 plus 2 is 9. So you can see we're starting to get a little sneaky here. Whenever we're dividing, we can subtract. And the first 3 examples or 4 examples, we were just one number minus another number, and they were both positive numbers. But here we're subtracting a negative, so we got to keep this in mind. Same thing here. So we've got negative 4. Maybe I'll write this down here. Negative 4, and we have 13 minus the minus 5. So you always are subtracting. So 13 subtract that number, which is minus 5. Now that is plus 5. 13 plus 5 is going to be 18. So negative 4 to the power of 18. So keep that in mind. I'm going to try to trick you sometimes on these by adding these negatives. So here we've got 2 numbers together. So I've got the 4s. Now I've got the 5 subtract, looks like negative 4. So I've got the 5 and then subtracting the negative 4. So 5 subtract negative 4. And then I've got the 6, 11 subtract, oh, it's not written there. Well, that's because it's a 1. So 11 subtract 1. So 5, so I got a 4. 5 subtract negative 4, that's the same thing as a plus. So 5 plus 4 is 9. 6, 11 minus 1 is 10. So you can see how at the beginning is really easy. Now it's starting to get a little bit more complicated, mostly because I've got 2 things happening here. So I got to make sure I line things up. But also, I am subtracting, for the 4s, I'm subtracting a negative number. And then for the 6s, I'm subtracting a number that's not even there. So I would say G is probably one of the more difficult ones, and it's one that you should really understand. If you can really understand that one, then you're in a good spot. All right, this is even more complicated. So I got 3 things here. So I got negative 3. 100 minus 41. And then I've got the x's, 23 minus 7. And the y's, 30 minus negative 1. So I've got the negative 3. 100 minus 41 is 59. And then we've got 23 minus 7, which I think is 16. And then I've got this one. This one was 30 subtract negative 1. So I'm subtracting a negative, which is going to be an adding. 30 plus 1 is 31. So that one is also kind of sneaky because there's lots of things going on. Let me just zoom out here. Okay, so we're going to go on to the next one in just a moment, and we're going to get some special results that come out of all of this. So we're going to keep that in mind.